Hello everyone, welcome back to the Core of Everything. Do remember to follow us on Twitter at @thecopod and on Instagram at @copod. Today we're going back into part 2 of mass extinctions, where we're looking at the death of the dinosaurs and are we currently going through a mass extinction? We're absolutely dead excited for this one. Then we get to our fifth and probably most famous
Old Faithful
mass extinction, which wiped out the dinosaurs, the Cretaceous Tertiary, or KT. So Cretaceous is with a C, but K I think is shorthand because C is already taken.
German, maybe?
It could be. I thought C is already taken because of Cambrian.
Right.
But yeah, it could be a German.
Cambrian might
derivation.
be CM. I think one of them is.
Okay.
I'm not sure. But,
okay.
Oh, no, you're right. You're probably right.
No, I don't know.
No,
but then,
we learned earlier that I don't know the geologic timescale, so I have no right to.
Well, just check your screensaver.
Yeah.
And this happened. So this KT extinction happened 65 million years ago.
It's worth saying, if I can, that it's also known as the KPG, which is the Cretaceous Paleogene. So just kind of we're talking about different divisions of the geologic timescale there.
Yeah, exactly. I think tertiary is hotly debated now. I wouldn't say hotly debated, but
right.
It's like it's just cause where some people would rather use stuff like Paleogene and Neogene, and some people like to use tertiary. But I think I'm not sure. But so anyway, this very sort of early, well, modern, I'd say, extinction relative to all the others 65 million years ago wiped out the dinosaurs.
Yeah.
And most people agree that it's a huge meteorite.
Yeah, a big asteroid that's coming in as our impactor.
I need to define these definitions between meteorite and asteroid next episode. That literally is what we're going to do for next episode.
That's on our bucket list. And the reason we think, or our kind of main line of evidence, is basically this thing called an iridium anomaly. So iridium is an element in the transition metal, so basically, in the middle of the periodic table, and it's quite rare on Earth, particularly at the surface, but it's abundant in meteorites, a material that comes from space. And we found at this sort of 65 million year boundary, we have found this iridium anomaly. So basically, iridium is low as you're kind of going through your rocks, and then suddenly you find a peak in it, and then it goes back to being low again. And we found this across Europe, in America, and kind of Central America as well. And it was deposited as a single layer on top of the rocks all over the world. This kind of hypothesis was first put forward by Alvarez in 1980, and actually I saw a great picture of Mr. Alvarez, I can't remember what his first name is, or maybe Doctor, with his son as well, both of them standing together at the KPG boundary in Gubbio in Italy, which is where I've been as well.
Cool. It
looked very different. So basically, we've got this iridium anomaly, but you've also got a thin layer of clay. It's it ranges in size across the Earth, but as our impactor comes in, it sprays up a load of ejector material that kind of is.
Isn't clay like a remnants of it shows ash, isn't it? It's like ash that breaks down into clay, or is it something like that, or is that wrong? So
I think we're getting weathering of whatever was there.
Okay.
And so and it's just kind of fine grained material.
So essentially, you have iridium and this clay that's deposited everywhere around the world, which shows this single mass event,
something happened,
catastrophic event that happened
at this time
that correlates with the extinction of the dinosaurs.
Yes, yeah. And within this clay layer, we actually also find things like spherals, which is my research. So we can use these. So spherals are formed by high temperature processes, one of which is an impact. So our impact smashes into the ground, sprays a lot of molten or vaporized material, which then condense or solidify to form these little kind of spherals. They're sort of 1/10 of a millimeter, so tiny little balls of glass, basically. And when I say glass, I don't mean your windows, but kind of non-crystalline material. And we can find these in this clay layer, often in quite high abundances, which tells us we had some kind of high temperature event, very likely to be an impact. And your abundance of those, again, changes across the kind of the global distribution of this clay layer. Unfortunately, at at the Gubbio location. It's kind of almost the type location. Like, it's such a good exposure of the KPG that so many people have gone in and sort of dug out the clay boundary, that it's actually recessed quite far into the rocks now. So you have to kind of go in with a very long teaspoon, like a Sunday spoon, I guess, would work quite well. So we think, based on kind of calculations and models, we think the impactor was about 12 kilometers across. And there was a really good review paper published recently, actually, by Joanna Morgan at Imperial. That was Morgan et al. 2022 in Nature Reviews.
Is that your supervisor? You're just going to give a shout out? That's not, is it?
It's not. I can shout. I would love to shout out my supervisor, Matt Genge, but I'll shout out anyone in our department.
Just say his name, Matt Genge. Okay, let's move on. No, so there was a lot of talk about this meteorite impact, and as you say, this iridium and clay.
Yeah.
But then we had to find the crater.
Yes, yeah. We actually found this. It was on the Yucatan Peninsula, which is kind of in the Gulf of Mexico. It's an egg-shaped crater. It's called the Chicxulub, which kind of has quite a difficult spelling. It's got C's and X's next to each other.
Yeah.
It's about 180 kilometers across. Now, obviously, because this happened so many millions of years ago, 65, 66, things have happened to that crater. So on other planets, craters get retained because there's not geological processes. On the Earth, stuff is happening. There's erosion, there's plate tectonics, and so it's really hard to see these craters, but we can use things like seismics to look at where the layers change, see if there's like a bowl shape. Actually, they took a well core of somewhere near this area. I can't remember exactly where, but they found in this well core, when they brought it up, so this is basically a very long piece of rock that goes vertically through the rocks, and they found a fossil meteorite. So this is a meteorite that landed many years ago, and you can kind of constrain when it landed based on the rock layers that it's found in.
This is not in Gulf of Mexico, though? Or is
Yeah.
So this isn't like a remnants of that meteorite?
That's the question. So it was found at the 65 million year mark. Cool. It was about 2.5 millimeter in size. It was found by a guy called Frank Kite, who was at UCLA. And he published this work in Nature in 1998. The meteorite was a carbonaceous chondrite. We can talk about that more next time. But basically that means it's got very high carbon content.
And these meteorites are the oldest, some of the oldest in the universe, no?
Yeah, very primitive material.
Billion years.
Yeah. And so his suggestion was that this had come as a fragment from that larger impactor. Now, that is debated because meteorites fall randomly in different places at different times, and so it could be that meteorite just happened to be in that place. He suggested that because that meteorite is carbonaceous, then the whole impactor had to be carbonaceous. There's been quite a lot of work since trying to identify the nature, the composition of our impactor, because that has implications for kind of how hard it hits the Earth, what kind of speed it's going at, whether it breaks up as it's coming through the atmosphere, all sorts of things like that. So it was a serendipitous finding, but potentially has
Let's hope it matches
big
the
implications. Yeah.
But obviously, when a meteorite hits the Earth, it's not just the meteorite that, unfortunately, if you're a dinosaur around the Gulf of Mexico at that time, it'd be really unlucky because you'd look up at the sky and it'd be like, see this massive asteroid coming towards you.
Yeah.
But obviously, when it impacts the ground, there's a lot more things that happen. After that.
Yes.
And one of them is earthquakes and tremors that happen for weeks after. I assume weeks afterwards.
Yeah. So we get kind of these tremors that also cause, like they do in the modern day, also cause tsunamis and just movement of the ground. And actually, there's a really cool story that came out recently about one of these waves. So in North Dakota, there's a deposit of a seiche. A seiche is basically it's a standing wave of water. So kind of if you have a lake, these waves can get to very high amplitude, very, very tall waves. So we have this seiche deposit, and within this deposit there are fish fossils. And in these fish, they found these impact spherules, these glassy spherules formed by the impacts, within the gills of the fish. Now, this is really important because they didn't find them further into the fish. So that means that basically these fish ingested these spherules and then died quite quickly afterwards. So they didn't have time to kind of move through the fish's sort of, I don't know what a biology of a fish is, but the digestive system or filtering systems. Yeah,
that's really interesting.
And so,
and how are these so well preserved then? Because they're fish, so they're very soft.
Well, we have the skeletons, and we can kind of reconstruct sort of.
But the gills aren't like. So, must have preserved in like the soft.
Is cartilage preserved? I guess not, because that's kind of soft.
Yeah, I mean, I assume it's just laid down, and then you maybe even have this ash or this deposit that's very fine grained, so it's able to be preserved. But I mean, that's incredible.
It's very cool because
that's incredible.
And the spherals hadn't impacted the carcass either, sort of the rest of the body. So we can actually tell at what point that relationship was between the fish dying, basically this wave coming through and like launching these fish out onto the land, and when we had the impact spherals. So the impact spherals come first. This modelling done by Morgan et al. Actually, material moves at over 5 kilometers per second. So within an hour, it's moved over 8,000 kilometers. So it's moving crazy quickly. And then these fish are launched out in the water. And actually, the cool kind of sort of point on this is that they were able to, based on the growth of fish in different seasons, correlating to tree rings as well, that are showing us we have different seasons at that time, kind of distinct, like they currently do in North Dakota, that actually the fish were probably killed in springtime.
That's amazing.
So although we can't pinpoint the exact year this happened,
it was a cold March morning.
Exactly. Maybe afternoon tea time.
Yeah, exactly. Yeah.
Yeah. So it's amazing, kind of the work you can do.
It was a Tuesday.
It was a Tuesday.
Yeah, that's mad.
In the afternoon.
So you have this massive meteorite which kills the fish. So long and thanks for all the fish.
Yeah.
As Hitchhiker's Guide to the Galaxy. But at the same time as all this, people think there's also the Deccan Traps, which is, again, one of those massive volcanic eruptions that happened over... I think it happened in the boundary between the Indian and African plates, and these huge lava flows. And to this day, I think it's still 2 kilometers thick. I think too. So we're talking like that's a lot of lava.
That is a lot of lava.
And it's now equivalent of 500,000 kilometers squared. So that's after it's been eroded.
Right.
And it's estimated when they were erupting at the time, it reached half the size of India.
So presumably, with this volcanism, there are huge amounts of gases being released.
Exactly. So can you imagine? Can you imagine if you're a dinosaur? Like you're there over in Mexico and you're like, I see an asteroid coming towards me, I better run away.
Yeah.
And then for weeks afterwards, they're like wobbling, their legs are wobbling because of the tremors.
Yeah.
They're running away from a wave. And
no fish to eat.
No fish to eat. And they run over to the other side of the world, and then like there's this just horrifically hot orange goo coming out the ground. What is going on? Like, you'd be so confused.
You would.
Poor things.
You'd want to be a giant squid, really, wouldn't you? Just hiding at the bottom of the ocean.
Yeah, exactly, yeah.
Even then, things would get a bit tangy in the water, probably, as it acidifies.
Yeah, exactly, yeah. Oh, dear. Yeah. So, yeah, I mean, that's pretty much I say it in a nutshell. We described it quite in detail, but that's some of the things that were going on during this one massive impact. And those are our 5 mass extinctions.
So the question is, are we going through a 6th?
So, yeah, I mean, it sounds quite drastic after... We're not experiencing massive meteorites or huge lava flows, but we're sort of self-destructing. It's far less dramatic, but we haven't quite got that massive loss of species yet, but we're talking timeframes that aren't over 200,000 years or a few million years. We're talking over the past 100 years. So we're actually accelerating the rate at which species are lost. And we're well on the way to a nice, horrific mass extinction, because lots of species are becoming rarer. Now, I think what's important to note here is that when we determine extinction rates and if there's a mass extinction, we look at the background rate of extinction versus the extinction rate. And this background rate of extinction, because species die out all the time and have done throughout Earth's history, we know from the fossil record it should be about 1 species per million per year. So that's 10 to 100 species a year. And it's currently believed to be at a extinction rate of 1,000 to 10,000 times higher than that.
Gosh.
So more than 10,000 species per year are lost. And this is through, deforestation,
Yeah, it's huge.
habitat loss, over hunting, pollution, climate change.
It must be really hard to estimate that number as well.
Yeah, how you just tally chart or something. How would you do it?
This was here before, it's not there now.
Yeah, exactly. Yeah, and then sometimes you count a species to be extinct, and then a nice happy finding that actually you found one single creature out there in the rainforest.
There's a very briefly. There's a in the Natural History Museum has two wings, extinct and extant, so living and dead, and I think they have the architecture reflects this, so like gargoyles and statues and things of the extinct and extant. But since they made that architecture of the statues, they found one of the extinct creatures, and so actually.
They've had to move it to the extinct.
I don't know if they've moved it or if they've just left it, but I'd recommend going into the main kind of hall. I think Hintzer Hall it's called.
That's good. Well, I think it's projected that 30 to 50% of the extant, so living like species that we have on our planet right now, they'll be extinct by the end of the 21st century.
Wow.
Which is just a projection. I think I read that on an article somewhere, so it might not be true. But even if it's slightly off, it's still scary.
Just because of everything we're doing, it makes you wonder whether new species will arise.
Yeah, I mean,
that thrive off.
Or there'll be species that we haven't found yet.
Yeah.
Rather than in terms of evolutionary terms, we're talking across, like, if you're talking about the end of the 21st century, there won't be like this massive change of evolution and stuff like that. But there for sure there'll be species we've never seen before that'll just crop up, maybe in stuff like the Marianas Trench. Well, currently there are more than 37,000 species that are threatened to go extinct. Amphibians are the highest threat, so they're 41% of those species. Mammals are at 26% of species threatened. And the main threat of this is all exploitation, so fishing and hunting, and deforestation as well. But I read this review paper that came out in 2021 in Biological Reviews, and it gave an outline, and there are some critiques to this sixth mass extinction.
Right.
The first one is that there are exaggerated extinction rates. So the current extinction rates are based off the IUCN Red List, which is the list of endangered species.
Okay.
And that's not significantly greater than the actual natural background rate.
Okay.
But the problem with this is that the red list is biased because it takes all the birds and mammals into account, but only a tiny proportion of invertebrates like mollusks, like snails and squids. So if you include all the invertebrates, the extinction rate far exceeds the background rate.
I guess that's the issue, right? That our bias comes in that, like, most people, you can see a lion, and it's much easier to count lions than it is to count snails. So if you're losing...
It's probably a bit more dangerous, but yeah.
True.
It's pretty easy to run away from a snail.
Yeah. If you're losing lions, it's more obvious, more apparent.
Yeah. There's also... Previous extinctions are a lot more marine-based, whereas ours are now looking way more like I think ours are a lot more now terrestrial-based as well.
Yeah.
So it's another probably talking point.
Yeah. So it's kind of poignant that we're actually the only species now that kind of has the ability to manipulate the Earth at some kind of scale.
Yeah.
So there is responsibility there.
We're the only species that have had this ability to control and manipulate the environment like we do. So we surely have some responsibility. You can't say that a dinosaur has responsibility for an asteroid impact.
Yeah.
They're pretty helpless.
Probably not their fault.
Whereas we can actually control what we're doing to the planet and what we're doing to the species around us.
Yeah.
We're mere shepherds. Stewards of the earth.
Yeah.
It's not a funny episode.
Bombshell to land on.
A bombshell, yeah. Yeah. Heavy impact.
Yeah, nice. Well, maybe I can end it with a movie recommendation that beautifully sums up. There's Cretaceous Park, the budget version.
Not many people know about Cretaceous Park. You didn't catch on, did it?
Ice Age. Great movie, and actually explores these themes beautifully. I can't remember how many films they're up to now, but...
they've pretty much gone through every mass extinction.
Maybe they've hit all of them.
Yeah.
Genius. Yeah, great film. Thanks for coming.
Well, there it is. Thanks very much, everyone, for joining us. A bit of a depressing episode, but next, obviously, I've got a clear knowledge gap in terms of meteorites, so the next episode will be on meteorites, asteroids, comets, meteors, meteoroids, whatever.
We'll try and define all
We'll
these
try and
things.
define all these things, but spend less time on the definitions and more talking about how cool they are.
Yeah.
Thanks very much for joining, and join us again next time.
Bye.
Bye, 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 bye.